So let's do one more together. Let's look at number 7. This patient is 23 pounds and they are 11 months old. So according to that chart, they're going to fall into the second category, the 6 to 12 month age range. And first thing we want to do is calculate the weight into kilograms. And that's going to work out to 10.45 kilograms. So if we look at the table, the daily dose range for that age is between 3.6 and 4.8. So we're going to want to find out the dosing range for each of those. So looking at the weight, 1045 times 3.6. I'm going to just erase that so we got a little bit more room. That works out to 37.6 milligrams. And then we're going to do the same for the higher dose. And that comes out to 50.16 milligrams. And we're going to just round it up to 50.2. So our range is 37.6 milligrams to 50.2 milligrams. Now, if we look at the dosing table, we'll see that their normal daily range is 30 to 45. So we'll see that ours is a little bit higher. So that's really going to be too high of a dose for a patient who's that age. Okay, let's look at some of the application questions. We're going to calculate the following using either the dimensional analysis method or the ratio proportion method. It doesn't matter which method you use. You're going to come up with the same answer. It's really just a personal preference. Let's look at number 9. A patient takes 1 teaspoon daily of a medication with a concentration of 80 milligrams per 15 ml. How many milligrams are in 1 dose? So we're looking for milligrams. That's what we're going to be solving for. That's going to be our variable, so that'll be X. And there are 5 milligrams per teaspoon, or 5 milliliters, excuse me. And according to the concentration of the medication that's available, 80 milligrams in every 15 milliliters. Now you can see typically the mLs have been on the top in the past, but it doesn't matter as long as your units of measure line up. So we can solve for X here. 5 on the top. It's going to cancel this out. And 5. The milliliters are going to cancel out. 80 times 5. X equals 26.67 milligrams. Don't forget to put your unit of measure on the end. Okay, let's look at number 10. A patient needs to have 60 milligrams of medication, and the drug has the concentration of 120 milligrams per 5 ml. How many teaspoonsful will the patient take? Okay, so if we look, we have milliliters and teaspoonsful. These are different units of measure. So since the dosing available is in milliliters, that's what we're going to solve for first, and then we will convert it to teaspoons when we're done. So we're still looking for a unit of measure, so X is going to be in milliliters for the time being, and then like I said, we will convert it. The desired dose is 60 milligrams, and the available concentration from the pharmacy is 5 mils and 120 milligrams. So we can solve for X. 60 is going to cancel out. and the milligrams are going to cancel themselves out. 60 times 5, 300 ml over 120. And X is going to equal 2.5 ml. So now that we know what it is in milliliters, we can convert that to teaspoons. We know that 1 teaspoon equals 5 mLs. So right here, we're looking at a half of a teaspoon. And that's it. That's all there is to it. Let me switch markers here because this marker's starting to fade. And then we will flip to the next page. Let's look at number 24. This is going to be a good example of a prescription that you're going to see a lot in the pharmacy. And this is prednisone. And a lot of times these dosings are tapered. And so you're going to have different dose for every single day. Number 24, how many prednisone 5 milligram tablets are needed to fill the following prescription? Well, you're going to take 4 tabs for 2 days, 3 tabs for 2 days, and then you're going to take 1 tab for 1 day. The easiest way to tackle this is really just to write out every single day. And then, whoops, I forgot to write the 2 there. We don't want to forget that. The easiest way is to write everything out each day and then add it up. So that's exactly what we're going to do. So day 1, 4 tablets. And day 2, they're going to take 4 tablets. Day 3, it's going to be 3 tablets. Day 4, 3 tablets. Day 5, this is the final one, and they're only going to take that for 1 day, and that's 1 tablet. So 4 plus 4 plus 3 plus 3 plus 1 is going to be 15 tablets. And you're going to see this a lot. The pharmacist, or the doctor rather, is going to write the prescription with the directions, and they're just going to put quantity, and they're going to put QS, which means quantity sufficient, and they're going to leave it up to you to figure out how many tablets you're going to need. Because the doctor doesn't want to sit there and calculate it out. They're going to make you do it. Okay, let's look at number 25. How many milliliters of nystatin must be dispensed for the following prescription? Nystatin, you'll see this dosed a lot of times in newborn children who have thrush. And it's 1 milliliter in each cheek every 3 hours. And you're going to dispense quantity sufficient for 10 days. Okay, so how many milliliters of nystatin must be dispensed? Let's see, if it's every 3 hours, we know that there's, first of all, 24 hours in a day, divided by 3. We need to find out how many doses they need every day. 24 divided by 3 is 8, so we know they're going to have 8 doses a day. If they're taking 1 ml, don't let this confuse you, we have 2 cheeks. So 2 ml times 8 doses is equal to 16 ml. And we need quantity sufficient for 10 days, 16 ml times 10, and we need 160 ml for the full prescription. The biggest trip up on things like that when they say each cheek are that people forget we have 2. Okay, number 26, this will be the last one we'll do together. There are 25 milligrams in a teaspoonful of medication. You're dispensing 12 fluid ounces. How many milligrams will be in the bottle? Okay, well, first we want to see how many fluid ounces are in milliliters, because a teaspoon is 5 milliliters. Let me rewrite that so that's easier to read. Okay, 12, we know that there are 30 mLs per ounce, so 12 times 30 gives us 360 ml total. And we need to set up our proportion for this. So if we're looking at the milligrams, which is what we're wanting to solve for, that's going to be our variable. There are 360 ml in the bottle. We know that the prescription that's on hand has 5 mils for 25 milligrams. And our units of measure do not line up, so we need to rewrite that. Okay, now we're ready to solve for X. 360 on the bottom, we're going to put 360 on the top to make it cancel out. We're going to put 360 on the top up here. The milliliters are going to cancel out. We're going to take 360 times 25, and we're going to divide that by 5. And that's going to give us 1,800 milligrams per bottle, but we're not done yet. If the patient is to get a total of 9 grams for a full therapy program, how many refills will be needed? Well, right here we're in grams and right here we're in milligrams. So let's real quick convert 9 grams to milligrams. 9. And we know that there are 1,000 milligrams per gram, so we're going to move the decimal 3 to the right. 1, 2, and 3. So we have 9,000 milligrams. We're going to take 9,000 divided by 1,800, and that's going to give us 5 bottles. But the question is asking for how many refills. If we have 5 bottles, keep in mind, one of them has to be the initial bottle. So really, we only need 4 refills. Okay, so hopefully that will help clarify calculating oral dosage for patients. It's really not any different than setting up the original proportions that we've been working on the last 2 chapters, but it's just important to keep in mind that we are converting our household measures and metric measures appropriately. If you have any questions, feel free to post them to the discussion thread, and good luck working on the rest of your practice problems.